The last talk of the session is also from industry, from 2B, and the speaker is Surabha Agrawal, and he's going to talk about beyond labels, leveraging deep learning and large language models for content metadata. You managed?
I want to use my pen drive. Can I escape it? And then how do I? Yeah. USB drive. Yeah, it's fine. This one. Yeah.
And then I think that we should do like that. So we go slide
Slideshow. Yeah. Yeah, that's good.
Is good?
Yeah.
Okay.
Hello, everyone. Thanks for coming to my talk. This is Saurabh Agrawal from Tubi. I'm a senior machine learning engineer there. And today I'm going to present a talk on the topic of how we can leverage deep learning and LLMs to solve the problem of content understanding. So here's a brief agenda of my talk. I'll first talk about what Tubi is, and then I'll talk about the problem of content understanding in the context of Tubi. And then I will present a case study on a sub-problem of content understanding, which is how to extract genre-related information from genre metadata. And then finally, I'll talk about how we can use LLMs to further expand the state of the art in this problem. So to begin with, as some of you might be already aware, Tubi is an online ad-based video streaming platform where users can simply log in and watch movies, TV series, news channels, and a lot of other content completely for free. There is no subscription fee involved. And our revenue comes from the ads that we serve to the viewers while they watch the content. So Tubi is getting really popular in US and beyond. We have so far more than 74 million monthly active users, and we are available outside US as well. As of now, we are in Canada, Mexico, and Latin America. We are also labeled as most watched in the category of free ad supported based television. So now to talk about the problem of understanding content from using metadata in the context of Tubi. So all the content that we present in Tubi, we have a lot of rich metadata available, such as titles, subtitles, synopsis, and then a lot of other attributed information, such as the cast of the movies, and then the language, year, genres, and ratings, and so on. And this rich metadata is available from various sources such as IMDb, Reelgood, Rotten Tomatoes, to name a few. And understanding this, it is very critical to ingest this content metadata properly so that we can develop a good content understanding. And having a good understanding of content is very useful because it helps us understand the relationships across different movies and TV series that we have. And that further helps us in analyzing the user preferences and also improves the quality of recommendations. Furthermore, it helps in other problems such as handling cold start items and better organization and categorization of movies on the user's home grid, as well as also it informs our acquisition team and helps them strategize better to acquire new content. So now I'm going to dive deep on a sub-problem in this topic, which is basically how to extract genre information from the genre metadata. So to begin with, let's talk briefly about what a genre is. As most of us know, genre is a common way to categorize movies based on its various aspects, such as narrative elements, aesthetic approach, or the emotional response to the film. So this is like action, drama, comedy, romance. These are the common well-known genres. And They are available to us as a binary labels, which are typically unranked from various production partners and film websites, as I mentioned earlier. So as ubiquitous as genres are, and we all of us use to express our likings and dislikings in the content world, the notion of genre is not formally defined. Like there is no universal definition of genre that is accepted across different sources of genre metadata, as well as there is no fixed number of genres that everybody agrees upon. So this brings a lot of subjectivity and noise in the genre labels that we receive from various labeling sources. And additionally, movies can also belong to multiple genres, and which is often the case. And besides, like different genres can have different level of relevance to a particular movie. So this brings in more subjectivity because in a lot of cases, people do not agree on which genre is more relevant and less dominant in a movie. And this problem gets further aggravated on movies which are not so popular, which brings in more like less reliable data and further aggravating this problem. Furthermore, genres, again, some of the genres are very broad of a category, and there can be further nuances within that genre. So for example, like the two movies you see here, Gladiator and Die Hard. So both of them are action movies, and so yet they are very different. Like one is set in an ancient Rome setting, while other is in more like a modern skyscraper setting where you are having a combat operation. So keep treating both of them as action movies and treating both of them similar might not be very appropriate in many scenarios. So given all these observations, it's clear that genres have a lot of subjectivity, and also that it has more like of a notion of continuity, and might not be appropriate to use genre labels to encode them. And therefore, given this thought, we proposed to encode genre information in more of a continuous latent representation space, which is basically what we call as genre spectrum. The idea is to basically represent movies in this embedding space such that movies with similar genres are embedded closer and vice versa. So this is a 2D plot of genres of an ideal genre spectrum embedding space that you will imagine, where if you embed all the movies and color them with their most dominant genre, then this is what you will see genres as cohesive clusters. So now I'm going to talk about how did we learn genre spectrum embeddings. I will skip some of the details in the interest of time, and because they're also expressed in the paper and in the poster. So the overall idea is that we basically follow a supervised representation learning framework. So basically, we train a feed-forward neural network that takes in an input feature vector of an embedding of a movie. This basically encodes all the textual information that we have in the form of the rich content metadata that we discussed earlier. So it basically, you can take any off-the-shelf like language models like Talk2Vec, BERT, and now even the likes of LLMs to encode all the metadata into an embedding vector. This can be taken as an input to this feed-forward neural network. And the goal we train this feed-forward neural network to predict the genres that we have, using and the model is trained using the genre label data that we have. And this model is trained end-to-end. Once this model is trained, then the genre spectrum embeddings can be obtained as the output of the second last layer of this network. Yeah. And then once these embeddings are learned, next I'll talk about how we can evaluate them. So basically, evaluation of embeddings is always tricky. So what we did was followed the intuition that we basically designed a metric called genre similarity in the neighborhood. So for given any embedding in a space, we took at, let's say, top 100 neighbors and look at their genres. If the genres are similar to that of the query movie, then we believe that the embedding space is more aligned with genre information, and vice versa. So in this table, basically, we are just showing that we are comparing the genre spectrum embeddings against their textual embedding variants, basically the input embeddings. And what we are noticing is that on this metric, the genre spectrum embeddings perform have much better numbers compared to the textual embeddings, indicating that this embedding has been better aligned. Of course, also we are seeing more improvement on the movies which are less popular, which might be because of that the content metadata that we have is not that rich, and that's why genre spectrum embeddings are able to perform better there. We have these embeddings currently in our production system after we did multiple online experiments in the downstream machine learning models, and we observed statistical significant improvement in our KPIs. So now this is the last section of my talk where I'm going to talk about how can we use LLMs further in advancing the state of the art in this problem. So before that, I'll talk about the concept of microgenres. So as the name suggests, microgenres is basically it's a highly specific or a niche subcategory of a broader genre. And the idea here is that can we learn microgenres from a movie, from the rich content metadata of a movie, and then use those microgenres to represent a movie, rather than using the entire content metadata. And in a way, this idea could also be looked upon as a dimensionality reduction of the deluge of information that we have into some semantically meaningful microgenres. And at the same time, these microgenres are very specific, so they are not as broad as or as coarse as the genres, the regular genres. So here are some examples here. So for example, that what kind of microgenres one can get. So here are some movies, like some of them are very popular, Ocean's 11 and Die Hard. And you can see, like, for those main genres like crime and like Ocean's 11 is a crime thriller, so you can see a lot of microgenres like a heist crime comedy and crime narrative gone wrong and so on. So all of these microgenres are revolving around crime genre, but they are at the same time very relevant and very precisely trying to describe what the movie is about. And similar examples you can see in other rows as well. So once, let's say you learn these microgenres, what can you do with them? Well, as of now, we think that we can use them in as an input features, like I mentioned earlier, in the downstream machine learning models, like ranking models or retrieval models, or even in the business logic, like cold start models. Another important application could be that of an explainability part. Like, for example, you can use the microgenre common to the watch history movies as well as the movie that we are going to recommend and you can use that as the basis of your explanation. And it can be both user-facing as well as it can be used for model iteration and debugging purposes. Another important application of microgenres could be container genesis. By container here, I also mean like carousel. So basically, it's a row of movies or titles that you see in a typical home grid whenever you use this online video streaming platforms. So with more microgenres available, we can use them as a theme to construct these carousels. So far, like at least in Tubi, we have been mostly using the regular genres like action, thriller, and so on to create these carousels. But these microgenres can help us create more precise carousels and can create movies of like groups of movies with tight relations. So generating microgenres is also very challenging and even more challenging than what we discussed in earlier, basically in the genres, because there is no predefined set of microgenres available. There is, of course, no label data, and even if we try to set up a human annotation process, it will not be easy to scale and will have a lot of subjectivity. So then this brings up the question that what if we can use the might of LLMs to synthesize these new microgenres and then later on also use them to tag various movies. And then here, following this thought, we started off with some simple attempts. And what we did was that we created a prompt where basically we are prescribing the definition of a microgenre. And then along with that, we are basically then dumping the entire metadata that we have, like from various sources, into that prompt, and then asking the LLM to predict top 10 or top 20 microgenres. Let's say we also like put some additional prompts so that we can have it as to give it a confidence score as well as the rationale for every microgenre. So here's an example like what kind of output can we get from the LLM. So this is a movie called Jasper Taxes. This movie is basically revolves around the investigation of a murder crime that was motivated by racial hatred against a group of people. So as you can see, like all these microgenres, these are generated by the LLM, specifically GPT-4, and you can see that all of them are precisely focused on that topic, on the theme, and they sound very promising. Additionally, we also like noticed like the output produced by the LLMs, like the GPT microgenres, has a strong relevance in container genesis, as I mentioned earlier. So here are like all these posters of movies that are basically themed that have the same common microgenre, which is the air combat films of World War II, and basically this is the theme which is applying to all of them, and it appears out to be a nice niche subcategory of war genre. Similarly, here's another example where within drama could be a nice subcategory of inheritance themed drama, and all of these have common microgenre of inheritance. So given that right now this is again a very initial stage, this is hardly like last couple of months explorations, and we have a lot of things to explore here, and some of them are like right now like what we want to learn. We have like gazillions of microgenres generated because we are simply applying LLMs on every movie. So what is another challenge is as to how can you learn the relationships across these microgenres, and some of the microgenres are very trivially similar, like they're just plurals or singular version of each of the same and have same semantics. Some are semantically different, but then still there might be some kind of relationship or hierarchical structure across these microgenres. So the idea is that can we use LLM themselves or some simpler techniques to unveil this hierarchical structure across these microgenres, and then once that is revealed, then we can even get a so imagine in this hierarchical tree, this microgenres are sitting at the leaves, whereas the less coarser genres are sitting in the internal nodes. So if we can manage to construct such a tree, then this will give us even more rich information or rich way to encode all the themes in a movie by representing the movie along the paths in this tree. So that's one idea here. Another is that how can we improve the microgenre predictions that for every movie, and here we are again exploring the directions of like standard directions here, which are prompt engineering. We can do fine tuning. Also the chain of thought ideas are really popping up these days. So that is one of the main. And also the calibration of confidence scores that we are generating using LLMs. We are thinking about all these things. So with that, I'd like to conclude my talk and summarize that we presented with the 2 points that we gave we highlighted the importance of content understanding and showed that how they can be done better by using embeddings and with the help of case study on genre metadata. And we also showed like some glimpses of strong promises of LLMs in this field. With that, I would like to conclude and thank you all of you. Thank you all for listening to us. And now I'm ready to take any questions.
Thank you. Thank you very much. Any questions from the audience? So I will start with a question. So did you try to do any evaluation with the microgenres? Did you try to evaluate whether it helps or not?
No. So this is like a very recent part. In fact, like this part of the talk is not even there in the main paper. But this is more like some recent results that I have. So we are still doing some evaluation. So yeah, it's early stage right now.
And in the generated microgenres, did you see whether some movies lead to much longer generated microgenres text, or whether there is a kind of a similar distribution? I mean, I guess that it depends on the movie, how these microgenres are generated. Maybe for some movies it's easier and you generate a lot of microgenres. for other movies, the system might struggle. Did you look at whether there are differences in the generated microjonks depending on the movies?
Yeah, so I think this problem is observed more when the movie has like a relatively poor content metadata, like less popular movies. For them, we get we have some movies we have a lot of reviews and rich like textual data available, but for some movies we have like very terse synopsis. So for the movies which are very terse synopsis, there sometimes we get this kind of problems.
Okay, we have a question from the audience, so please.
Thank you for the great talk. I was wondering if you can speak to the safety concerns when you are using large language models for new genres, like for example, hallucination, and also maybe some genres might be offensive to people.
Yeah, absolutely. These are great points. So what this will we envisage a lot of like what do you call a cleaning of the micro genre, the output that we get from LLMs. But the good point is that this is more like a one-time thing, because once you get all these labels and you can do some kind of post cleaning, then the clean features then can always be used in the production. So we rely on a lot of post cleaning and that kind of stuff to solve these kind of problems.
By humans?
Yeah, by humans, or maybe some kind of by using some kind of like heuristics, business logic, and so on. Yeah, but some kind of human evaluation might also be needed. We will get to see how big this challenges turn out to be.
Thank you.
Yeah.
Yeah, please.
Oh. Hi, this is Tao from Amazon Music. Great talk, very exciting and timely. So I noticed in one of your slides, you list some confidence scores with each of the output from LLM. I'm curious if that is created by human in the loop labeling, or is that some other way of generating the confidence scores?
No, so these were generated by LLM themselves.
Oh, got it.
Yeah,
okay.
and that's why, and I believe like some of the calibration also might be needed on this. But from our, we basically examined by ourselves like few movies, like 50 to 100. Based on that, we found that they are not completely arbitrary, they're pretty relevant. But still a precise calibration will further help us get even better results.
Got it. Thank you.
Yeah.
Is there a question there? Yeah, please.
Yeah, hi, thanks for the talk. So actually, I'm wondering how do you control the GPT-4 output to prevent not outputting too many long-tail microgenres? So basically, what we observe actually, we also build a similar system. So actually, what GPT output is a bit random. Sometimes like the order of the words may be different, but actually they are the same microgenre. So in this case, actually, it may generate a lot of long-tail results. So how do you control that?
So I think if I understand your question correctly, you are asking like how do you solve the problem of avoiding too many microgenres that the LLM is generating?
Yes.
Yeah,
yes,
that's
correct.
a fair point. So that's what we are trying to do, some kind of clustering, hierarchical clustering, and this topic modeling on these microgenres that we're generating from this from every movie. And then once we get develop this clustering, then we can do some kind of processing on that. On that tree, hierarchical tree, and that way we plan to get rid of these microgenres.
So basically, the microgenre you show here is already after clustering of the raw output of the GPT.
No. Right now they are the very raw results here. So we haven't done any kind of clustering. Basically, what we found is that some of the microgenres are repeated across multiple movies. For example, that container genesis examples I gave, the air combat is actually they are being repeating across that. Of course, we did some kind of text processing to make sure that air combat or something, combat air, something like that. Those kind of pre-processing we did to make sure that if it is trivially dissimilar, we can group them. But definitely we might need even more to capture these microgenres which are actually having different words but semantically similar. For that, we will need a proper clustering and hierarchical clustering based methods, and that's what right now we are exploring.
Okay, I think that you can take the conversation offline. One last question from someone online. How would this work translate into other domains like e-commerce?
That's a great question. I think, yeah, I think I'm just thinking out loud right now. Basically, even in e-commerce domain, if you have whatever the products that you have, if you can manage to get a lot of content or textual data that describes those products, then I believe then LLMs can be used to create such kind of like nuanced categories and all. I think the key is to have a lot of textual data that describe or talk about that particular item that you have. That's what I can think about right now.
Okay, there are other questions online. You can check them out and answer them, but
Okay.
that's all what we have time for. Thanks again. Let's thank all the speakers again. This ends the session. So there is a lunch break, and also the posters are still on display outside. Sessions resume at 2 p.m. Thank you.